we can identify which scale. This can be utilized for these scales, these procedures like frequency, mode, etc. These procedures can be used with these scales. That is given in this next slide. So how to clean your data? We have collected our data, that is raw. Then we have to clean it. There is two types. One is cleaning, one is cleansing. Cleansing I have not put. So what is the difference between cleaning and cleansing? So in cleaning, we are sorting, evaluating and preparing the data for storage or transfer. So this cleaning process, we are removing inaccurate data, duplicated, everything which is not for used for us. Like cleaning and scrubbing the utensils, we are cleaning and scrubbing the data. This is cleaning. Okay, we are removing the errors, duplication, everything we are removing. Before analyzing data for research purposes, we have to clean it. Because we have put a double entry, sometimes the errors may be there, like that. So we should have, sometimes we have corrected files. So data cleaning is mandatory. But cleansing is what? The cleaned data we can standardize and even validate. That is cleansing. Next slide. So why we have to same thing I have written here again. So some things errors to be removed. For that we are cleaning the data. Next slide. So 3S. Complete. We have to see if all the data are there without missing anything. Consistent. From beginning to the last, whatever we have collected, whether it is consistent. And then if it is correct, we have to see. Outliers. Here one word called outliers. What is outliers? What is outliers? What is outlier in a data? Any data that stands out, it is not relevant. It is, if you are drawing a plot, it will stand outside. We can't use it for our data. It will be totally irrelevant. So that data is called outliers. You can draw some maps or anything or plot some diagrams. You will stand, that point will be an outlier. Okay, next slide. Then, so for that you can use some templates etc. to clean the data. So again the same thing, resolve the missing data and review the complete data set for accuracy. After accuracy only you can utilize it for your thesis. Next slide. So this is the flow chart how to clean the data. So you have the raw data is called the dirty data. So by various methods you are cleaning and then you are warehousing the data. After cleaning you have to store it. Before cleaning also we have to store it, and after cleaning also you have to store it, because sometimes we may miss something, we could have deleted something, so we have to store both, and then after that only the target data, it is the clean data. Next slide. So this is also the same similar chart only. So you check for spelling errors, duplicate, missing data, everything. And then finally a clean report we are getting. Okay. Next slide. So its importance also is given for your final thesis. Accuracy of analysis, you need a clean data. Next slide. So presentation. How will you present? You organize, summarize, and then you use variety of tools. So you use attractive. So you have to present the data in a neat way. So the numbers, figures, etc. are presented in tables, graphs, etc. And interpretation you can state as a text so that they will read. Next slide. So it is in the text form, tabular form, graphical form. So table, simple and complex, that is quantitative and qualitative data. For visual, which type of figures we can use. So text form, just you have written whatever, it is understandable. Okay. So you can use small appropriate tables also along with figures. But don't repeat the matter. Whatever written, don't repeat again in table, again in figure. It will give you boring to be, and pages also increase in dissertation and all. Now for that they say 170 pages only, and now online 75 pages only for the MD. So we can't put everything. So we can't repeat same matter again and again. Okay. Then keep only the findings of the present study in the result section. Don't read everything in the previous section to come in the result section. Next slide. So you read the first line, it will be so explanatory, that is not required. The second line only, it will be so 7.9 to 7.8 after intervention. In the first, it is given in 2 lines. That we should make a single line or neat presentation or understandable presentation. By reading it, he will know everything. Like that, it should be so catchy. So this is the meaning of this line. For example, text form. Next line. Then tabular form. You can use simple tables, etc. First step of interpretation is table. Okay, it summarizes the large data in a single table. Next slide. So table guidelines, table should be numbered, that we all know. That number should come in the index column also. And whatever the table should be brief, the size, vertical tables only everybody will like to see. And it should be chronologically, but alphabetically I don't agree. But maybe some authors may ask so, I don't know. But chronological tables are important, and geographically, and then the space, etc. should be mentioned. Next slide. And on everything, the tables should not be too large. It's all I told. Footnotes are very important for the tables. Is the footnotes. Next slide. And symbols. If you are using symbols, use in a sequence. And all the meaning of the symbol should be in the footnotes. So the standard deviation, etc. should be shown in the table. Okay. So next slide. Simple tables and complex tables. If we are having multiple sets, we are using complex tables. Simple table, next slide, will be just a column and row. That is a complex table. You get various values in the table like HB, SR, etc. And that before treatment, after treatment, this and that, all that. So this is a complex table. Okay, it has subcategories in the complex table. Next slide. How to arrange the table. So this is the way you have to arrange. You can get every information when you see, and all the footnotes has the not significant, etc., etc. And if it has an ostrich sign, the dagger sign, anything should be explained beneath. Next slide. So this is the same thing. See this table and see this table. The same table, it is in a presentable form so that easily understandable. That we have to use our knowledge and present like that, so that by seeing itself one gets lot of ideas about the HbA1c, etc., the blood pressure and the cholesterol level, etc. Than this table, that table is better. So we have to choose a right table. Next slide. Then this is all same only. Next slide. These are complex tables. Based on whatever you are going, your thesis, you can put such tables. This also slide change, like a line diagram, we can draw line graph. You will understand now that in our place, lot of labs are giving like this also, line diagrams. In famous labs they are giving only. So exactly we can see the results without even going through this. The readings we can go, we just come down, the values are come down like that. So this is a line graph. Next. So visual or graphical form. Tables are also explanatory, but this graphical form has more impact because the graph, it will be so catchy also. So we have self-explanatory graphs. Next slide. So this graphical bar design for data presentation we use. For numerical we have histogram, box plot, etc. For numerical. For qualitative data also we are using bar charts. Then for 3D graphs we can avoid, because for medical this one it will not be looking good. It will not be looking effective, so we can avoid this. Next slide. This is a bar chart. These values are represented in a bar chart, easily understandable. It's a simple bar chart. Next slide. This is also a simple bar chart. You have an x-axis and y-axis, that's all. And you plot the values in the, all this we can use a graph pad prism software and draw this chart. We can choose whatever color we want. So you can use it in an Excel spreadsheet. We can put our data and get this beautiful charts. Next slide. This is a multiple bar charts for too many data. If you are having regarding a particular thing, we can use multiple bar chart with different colors. This is also multiple bar chart. Usually this stack, you put the slide, vertical bar graph. Why it is stacked means we can show different colors. For example, in a college some people are joining Sastra, some people are joining another branch in 2019. In 2020, some people are students are joining. So you will put different colors for 2019 one bar, but different colors for the number of students. So it will be so. If you see the chart itself, you can understand how many students joined for Siddha, for Ayurveda, like that in 1 year. So this is called stacked bar chart. It is showing different color in a vertical bar charts. Next slide. So for quantitative data, we always use histogram is better. Histogram is a continuous bar chart. Next slide. This is the histogram. So it is a continuous bar chart, and for this is very useful for a quantitative data. They have shown the frequency of cholesterol. Next slide. So frequency polygons. This is also like a bar chart only, but that interval we have lines drawn, straight lines drawn across the bar charts. Show the slide. See, the lines are drawn. The values, you can see the lines drawn. This is called a polygon. Next slide. This is also a type of polygon. Next slide. So this line charts, here we see the death rate, birth rate, etc. By seeing this itself, we can see the mortality rate has come down in 1980, like that. So actually, whenever you present something, you have to put the latest data only. Prevalence and anything, students will come and hepatitis, they will put to the 1980 this reports and all, they will collect and put. I have also done the same mistake, like that we should not put. Whenever you present, we should provide the latest data. Then only it will be good. We should provide 2020, what is the death rate? Or 2024, what is the death rate? Like that. So this is called line charts. Next. Same thing. For men, women, they have shown the systolic BP. Next slide. It's also same. So pie chart. Pie chart we use for nominal data. For see, in pie chart we should not use more than 7 pages. Usually it is for less data only we use the pie chart. Next slide. We can use different colors for the pie chart. Yes, different colors. Usually it starts from the 12 o'clock position. The maximum comes first. Then the minimum, this one minimum data will come the next, like that it will come. By seeing that and the various colors, we can how much percentage the infanticide is there, homicide is there, like that. So if, more than 7, it won't look nice. Usually pie charts for less than 7 wedges only they will use, or 3, like that. Next slide. So scattered plots. These are plots, so x-axis and y-axis they draw the scattered plots. Next slide. Next slide. See this dots. Each dot is a data. Each dot is a data. In that, the last one is going up. Now that is an outlier. Okay, or the one that is in the down. That doesn't go into the data, means that is an outlier. This is a scattered plot. This is also again a scattered plot. This is box plot. The scattered plots, all dot plots are all x-axis and y-axis. In that we have the details here, and with that we put a point, means that is a data. One point is a data. This is again a box chart. Next. This is important. Why? Box and whiskers. The whisker is it denotes outlier. Okay, it may be down or up. So this may be an outlier. Thus interquartile range they are saying, that will be the middle 50 and the upper quartile, lower quartile. Lower quartile means percentile. Within 25 percentile will be in the lower quartile, and the upper quartile above 75%, in the middle will be 50%. So in the quartile we will not take below 25 or above 75. So the whisker is and all outliers. Okay, this is also a type of representing a data. Next slide. So see, they have put first quartile, third quartile is the upper quartile, then first is the lower one, then how the maximum and minimum value are distributed they have shown. Next slide. This is a population pyramid. This everything we can describe in tables or words. But if you put a population pyramid, you can see it better. It's also a bar diagram only. This is also a histogram. It is a linear way. You have seen vertical. This is in the linear way. For election result and all, they will put in a linear way. Next slide. This pictogram. Pictogram is images or icons. We say no. If it is going to rain, there will be a umbrella symbol. This is used for epidemiological studies. Pictograms only they use so that it will be so understandable and easy. So this is a pictogram. Next slide. This is for the stool they have put. So next slide. Map diagram is also there. This usually we use for population, rainfall distribution, forest distribution, or we can use for elephants, tigers distribution, anything. This is called a map diagram. For COVID, this was used. Next slide. We have this important this one, software tools. Certain tools we use like formulas alone we can use. For certain things we can use Excel sheets. For certain diagrams we can use GraphPad Prism, Sigma Plot, and this statistical package for social sciences. This is also a paid one, but for 30 days it is unpaid. So you can use 30 days like that you can use. The SPSS is also a good software. Then one is R. This R is also an important interactive software they say. This is also a good software. Okay. Then GraphPad for all this one diagrams, we can buy diagram everything. GraphPad, this is also paid software. And anything in doubt in statistics, you go to statistics how to. Statistics how to. That website is free and anything you want to refer, you can refer from that website. Okay. Next slide. We have free websites also from WHO. Lot of free websites. Next slide. Next slide. This is all the papers, etc. regarding statistics. Next slide. Next slide. So that's recommendation only. You can run. Next slide. Of ICMJE. Next slide. Next slide. This all is given in the ICMJ guidelines for tables, how to use, etc. I prepared it, so I didn't want to delete it. Next. So, what is this data? What is this data? It is continuous or discrete? Continuous, yes sir, thank you. It is continuous data. Likewise, you can ask small questions to your students also. Because statistics is a very dry subject. Next slide. So this all what is represents line chart. This all we have seen already. Next slide. Next. It's over I think. You go to that 6. So how to present your statistics? Okay. And we have to select appropriate statistics, descriptive and inferential. Next slide. So you have to know what is descriptive and what is inferential. Next slide. Here also you use the ICMJE guidelines. Then it will be easy for you. So you take all the reported results. To verify, you take the ICMJE guidelines. Next slide. And use appropriate statistical tool. We can't rely only on the hypothesis, like p-value, etc. We have to go with the reference and methods also. Next slide. So how to select the statistical test, which statistical design it is used, which test you are going to use, etc. Everything is available handy in the internet. That to statistics how to. From there you can take the proper statistical method to do your data analysis. You can give to the statistician also, but if we do and find an error, then it will be easy for you to learn. Even I learned so only reading like this because statistics is difficult. Next slide. So descriptive. Descriptive is just you summarize the data. In inferential, you draw a conclusion. As we say, inference means draw a conclusion using the statistical test we have made. Next slide. So descriptive statistics, it helps to analyze or understand the data. Then it summarizes the data of the. We can't take an entire population, so sample has to be taken. It comprises of frequency distribution, measures of central tendency, and measures of variability. Next slide. So our goal is to summarize the extensive information of the form of numerical data into a small information so easily understandable, and you have to apply it for our especially in the medical science for the origin of diseases, treatment, etc. Effective treatment and all, we have to apply this descriptive statistics only. Then in nutrition also it helps to design a healthy and balanced diet. Next slide. So it manages the data and present it in a summary table. It helps to manage the data and present it. Okay. So in the cricket match means they are maintaining the records. No, that is all descriptive data. This player has got high records like that and all. They have the table. That is the descriptive statistics. Next slide. So importance of it is that it is important to understand the user statistical data and which to use and the problem statement. Okay, it gives a idea of the data. Next slide. So measure of central tendency. This is the average. You know how to calculate the average. So you have to calculate everything and divide it by the number of samples. Next slide. They are arithmetic mean, geometric mean, harmonic mean, etc. Arithmetic mean we all know, adding and dividing. Geometric mean the square root of n like that. Next slide. And then in descriptive statistics, furthermore measures of dispersion. This is the data will be dispersed. That we have to understand, and so we have to see the measures of dispersion also. And there are absolute measures of dispersion and relative measures of dispersion. Next slide. So there is a range, you know, from 10 to 50 like that. Range is there. Variance means from the center how it is deviated, how much it is gone far away from the mean. That is variance. Then we know standard deviation, mean deviation, and quartile. I said not 25%. Yes, 25% is the first quartile, and the middle is the second quartile, and 75% is the third quartile. Next slide. This all we can put it in our table. So measures of dispersion, when we want to quantify the variability of data, we use measures of dispersion. So in central tendency also we know that mean median mode is a central tendency. That measures we have to see all in descriptive statistics only. Next slide. Next slide. Inferential. This is the main part. So whole population we can't take, we take samples to draw the inference from a large group. Next slide. So advantages. So it helps researchers to test their hypothesis, to answer to a research question and derive the meaning from the result. So research inferential statistics is more important. Next slide. So accuracy depends on the representatives. So we are just choosing by a chance. You choose some random selection. So the representative should be proper. We get the good result. So the equal chance for everyone. You can't see take only one certain people from your place alone like that. You have to give equal chance to large population. One we have to randomly pick up so that the sample is more representative. Next slide. Then hypothesis testing. This is more, null hypothesis, alternate hypothesis, etc. So hypothesis testing is more mandatory, and then you reject the null hypothesis and always accept the alternate hypothesis. Like you say, height is not equal to shoe size. That is null hypothesis. But alternate hypothesis will say height and shoe size are dependent. If persons are taller, they will have larger shoe size like that. That is alternate hypothesis. So regression analysis, this are the two classification of inferential statistics. There are various methods to test the parameters of the both. So regression analysis, what is that? Relationship between independent and one or more two independent one dependent and one or more independent variable. That is the regression analysis. How to estimate means one dependent variable. For example, eating ice cream in a summer. So ice cream under hot weather will be a dependent variable. So independent means boys and girls like that, salary of boys and girls like that are independent variable. So that analysis is called regression analysis. Next slide. Hypothesis testing. We have lot of tests all are in the net. All tests are available online. These tests can be used. F test, Z test, T test, etc. To find out the probability and all. We use the T test in the table. ANOVA test, Wilkinson and sign test, etc., etc. And regression, we have 4 types of regression analysis. Next. So hypothesis testing, you use to test the assumption and draw a conclusion about the population from the sample data. Okay. So null hypothesis and an alternate hypothesis is there by conducting a statistical test of significance. And then a conclusion is drawn based on the value of the test, then critical value on the confidence interval. So hypothesis test can be left child, right, and this is all based on the statistical the curves. Next slide. So what is parametric and non-parametric? Non-parametric, it will be that will not have a normal distribution. Non-parametric, no normal distribution. Parametric, see, we make assumptions about a population's parameter, mean and standard deviation. It will have a normal distribution in parametric. Next slide. So this is the way to test the parametric and non-parametric. Non-parametric, we can use a chi-square table that you will not have any instrument. It is simple formulas are there, so you can do the non-parametric test. Simple, it is shown less affected by outliers. Okay, so the benefits and for non-parametric and parametric is given. Next slide. This is also the benefits of the parametric and non-parametric. Lots of non-parametric tests are there. For parametric, we use the ANOVA test. When there are a lot of variables, we use the ANOVA test. Next slide. So distribution. So you know spinous, kurtosis and all the peak and the flat. Then in the non-parametric test, chi-square test, you have the chi-square formula that I have not mentioned here. So we use which type of data tool we are using. We have to choose like that. So for our data, which will be convenient, we have to choose. Next slide. So conditions for non-parametric test. One or more assumptions of a parametric test have to be violated, and sample size is too small means we can use a non-parametric test, and outliers cannot be removed easily in a parametric, so we use a non-parametric test. So this very skewed distribution also we can use a non-parametric test. Next slide. These are the names. Already I have mentioned all these tests. One way, ANOVA, etc. And then these are all the names of some tests. This all we have in the app. Next slide. And simple formulas also we can use this test. These sample sign test. I have already mentioned all these tests for where you use between which data you can use all these tests. Next slide. This is also the same. Again, whatever I gave in the table, it is explained. Next slide. Same. Next slide. So this is a parametric test and non-parametric. They are very important in the statistics. Next slide. So, for example, to compare girls' weight and boys' weight, which test you will use? Purpose is compare two independent samples from the same population. So you use in parametric, you use unpaired t-test and man-made test in non-parametric. Likewise, from this example, we have to take what test we can use. So we need to do that test means which statistical tool we are using in parametric and non-parametric. This slide is showing only that. See what to compare the weight before and after a feed. So it will be one sample t-test because same person before and after feed. So one sample t-test is enough. Like that, examples are given. Next slide. Same thing. The examples and which test for parametric and non-parametric. So regression analysis. How one variable will change in respect to another variable. That is regression analysis. So there are various types of regression analysis. The most commonly used is linear regression. So linear regression checks the effect of a unit change of the independent variable in a dependent variable. Next slide. So regression coefficients are also used to predict the unknown value of a variable using a known variable. So in an independent variable, how it causes the effect in a dependent variable by determining the equation of best fitted straight line. This is called linear regression line. Next slide. So this all interpretation, how we are going to interpret. By the curves we draw, we have to interpret whether there is any relationship between dependent and independent variable like that. Next slide. So inferential, all what to summarize inferential statistics and descriptive statistics. In this, conclusions about the population by analytical tools, and there you are just having the data and you are quantifying the characteristics of the data. So in this hypothesis inferential is only the final thing. So hypothesis testing, regression analysis, everything can be used and it is used to make inferences, etc. In that we are just describing the characteristic of a known sample or population. Next slide. So activity. So in this, time in seconds, where will it match? You can match 2-3 time in seconds. Just answer at least one. Okay. One more. What data it is? Okay. Continuous also you can put, no? Like that. Like that, temperature also you can put. Next slide. It is the answers are here. Because there is no time, I am just running the answers. So it is the second one also Fahrenheit. It's a continuous data. Then the D is it is interval data is there, no? From just 90 to 98 like that and all. Then H. What is H? H is quantitative data. Likewise, we can give activities. This is an activity actually I am supposed to make you do. I was asked to, but there is no time, so you won't even take this slide. Okay? This is very simple only. Male, female means will come in binary. So age in this one is a continuous data. Then C is a ratio data. Like that, we are having the qualitative, quantitative, etc. ratio data, etc. Discrete, continuous. Read again, we will very simple only. Next slide. So these three, you say what is the descriptive or inferential statistics. Just we will finish with this activity I think. So in a study, in a school, so students are assessed anemic or not anemic. What type of statistics is there? First one, they are saying boys, girls, vegetarian, non-vegetarian, etc. Are they having any inference here? No inference, no. So it is descriptive only. There is no. Third, you can say whether it is both descriptive and the third is also descriptive only. But if you are having some inference in this, there is no inference actually. But if there is any inference, you can say inference. But it is also descriptive only. Just you are having the data. You are not having any inference from that. So this next slide. This is a bit difficult because we have to go this paired t-test, unpaired t-test, like that. So when one way ANOVA, multiple ANOVA and all. But this also is an activity only. The single group means how many listen? Single group. Pre-post assessment, discrete data. Can put the answers. Next slide. So this test you can use for the single group. For using mainly we use the t-test, unpaired t-test and paired t-test. You see the D for same group pre and post. That we have used the paired t-test. Same group pre and post assessment. Okay. Likewise, we have to analyze which type of data this test can be used. From that, we will find out the p-value, the probability value. Next slide. Similar only. Here also multiple data is there, male, female, etc. And their cholesterol, FBS. We can add HbA1c also. And then with this we can draw charts. What type of charts and all we can draw with this data? With this data, what type of charts and all we can draw? Any chart we can draw, bar charts, pie diagram, but more than 10 is there, but it will look so clumsy. So any type of charts we can do with this data. Like this, always we can't give us a table, so we will give bar charts. Okay. Next slide. Next slide. Anything is there? Additional info is given and all this all definitions we were given. So should I explain this, sir? Okay. Okay, sir. Any questions? So statistics, we have to read a lot regarding statistics because we depend on the statisticians. We have to apply on our own. We can buy a graph card, prism, and draw various bar diagrams, colorful diagrams on our own. We can present our data in a presentable form. Thank you.
Any queries from the delegates? Thank you so much. Now I request our principal sir to kindly visit Dr. Nalini Saraswati.
Hey भैया सर
I request all the delegates to kindly enter the link and log in with their credentials to fill the post test. Sorry, feedback form. Not post test, it's feedback form. Feedback for all the 3 sessions. 6 sessions. Hope all the delegates have filled their feedback form. If anybody is having any problem, please raise your hands. Okay, give your names to me. Please give your names to me. All.
user ID password all is okay. From the one claim. ఇలా రెండు చేస్తాను
ಮೇಡಮ್ ಅದೇ ಅಲ್ಲಿ ಅಲ್ಲಿಂದ ಅಬ್ಸರ್ವೇಷನ್ಸ್ ಆಗ್ತಿದೆ ಸ್ವಲ್ಪ ಟೈಮ್ ತೊಗೊಳುತ್ತೆ ಚೆಕ್ ಲಿಸ್ಟ್ ಟಾಪಿಕ್
इस साइड से ले लीजिए, इस साइड से। ले लूँ क्या? हाँ ले ली, इधर से।
normally sensation ಎಲ್ಲ ಆಗಿದೆ.
ಲೇಟ್ ಆಗಿದೆ ಇವತ್ತು ನಾಳೆ
Sir, a small announcement. All the delegates, there is a technical problem in the NCSM, so we have called them. Nobody is getting entered for the feedback, so they told that technical issues will be rectified tomorrow. You can fill this feedback tomorrow also. Okay. Thank you one and all. Thanks.
ನಾಳೆ ಇಷ್ಟೇ ಇರೋದು ನಾಳೆ ಬಾ ಅಂತ ಹೇಳಿಲ್ಲಲ್ಲ ಬೇಡ ಹೋಗೋದು ಸಾಕಾಗಿದ್ರು
Both the faculty.